Hi, this is Ava McBride and Aurora McBride, and we're doing a 5th grade math lesson. So, who can tell me the difference between an improper fraction and a proper fraction?
An improper fraction is like, say there were 6/5. That's more than the whole. And a proper fraction is less than the whole or the whole.
Okay, when you have an improper fraction, the numerator is bigger than the denominator? Interesting. I think you're right. When we're talking about denominators, what's a common denominator?
A common denominator is, like, say you're trying to add together 1/5 and 2/20. You can't add 5 and 20 together, so you would have to find a common space, something that both of the numbers could equal.
Okay, so give me an example with that problem you mentioned, 1/5 plus 2/20. How do I find the common denominator?
You could do 20 plus 20, and that would get you to 40. So you could see if 5 also fits into 40.
But would 5 go into 20?
Yes, it would. That's another way to do it.
Okay, so we could make 20 our common denominator?
Mm-hmm.
All right, well, show me how to fix this problem then if we need to find a common denominator.
So, if we have our 1/5, we would multiply this by 4, and that would get us to 20 on the bottom.
You have to do the same thing to the numerator?
Well, yes, you do. If you're finding a common denominator.
So whatever you do to the denominator, you have to do to the numerator too?
Mm-hmm. Whatever you do to the bottom, you have to do to the top.
So that would turn your problem into 4/20 plus 2/20?
Which would equal 6/20.
Okay. And then would you leave it like that?
Yes.
If you were doing this problem, would 6/20 be...
Yeah.
Would that be the most simplified form that you could find for 6/20?
No, I guess not.
Okay, so how could you reduce that fraction? Or simplify it?
I've only done one problem with simplifying. I don't know.
Okay. Well, what goes into both 6 and 20? This is a refresher, I thought.
2?
You haven't reduced fractions before?
Only like once.
Okay. So find a number that goes into both 6 and 20.
2.
Okay. So to reduce the fraction, I thought this would be a refresher, but this is good because I'm supposed to be activating your prior knowledge, but it's good to know what you already know. And what you do to the top, you have to do to the bottom, right? Okay, so if you wanted to reduce it 6/20, you could divide them both by 2 and get 3/10. Awesome.
Mm-hmm.
Thank you. Well, it's good to know what you know and what you don't know because I try not to do too much with you ahead of time. So I don't, I'm not giving you more information than you already come into it with, but let's see, what was my other question? Sorry. Okay, so why do we need, and again, you're every student, so normally I would be calling out different students, but why do we need a common denominator to add and subtract fractions?
Because say you're trying to do 1/5 plus 2/20.
Yeah.
That would give you 3/25. That's not...
Can't do that.
No, you can't do that.
So when you're adding and subtracting fractions, they both have to have the same...
Common denominator, yes.
Yeah, you have to have them have the same denominator. Yeah. All right. We'll talk about that more because we're going to be reviewing some important math vocabulary related to fractions and mixed numbers. And by reading and doing a little practice with adding and subtracting fractions, by reading this book called Mixed Numbers by Claire Piddick. Are you ready? Alright. These are some mixed number models. Pizza models. Are you hungry? Let's look at pizza models. So there's your whole pizza equals... Okay. First uncut and then into 8 equal slices. So one whole can equal 8 equal parts, or 8 eighths. That's a fun one to say, isn't it? How do I get that full screen? Because right now it's like cutting off the bottom of the book.
Here, press this down here.
Okay, thank you. I learned so much from students. You've used Epic more than I have, haven't you?
Yeah.
Okay, so this slice is a fraction of the pizza, 1 part of 8 equal parts. This fraction is 1/8. Put them together. A mixed number has a whole number part and a fraction part. So if you have these 2 pizzas and you have 8 slices from this pizza and 1 slice from this pizza, that's 8 eighths plus 1/8. That's going to give you a mixed number of 1 and 1/8. The top of the fraction is the numerator and the bottom of the fraction is the denominator. Which you guys, oops. I know, it'll give you, I guess, it will give you the definition if you click on it, won't it?
Yes, if you click on the word, it'll give you the
That's good to know. That might come in handy. Alright, here's some shape models.
8,
Oh. You can use other shapes to show wholes and parts. 1 whole equals 5/5. In this rectangle, 1 whole equals 6/6. And then they have a mixed number. So this square has been, each of these squares have been separated into 4 parts, 4 equal parts. So this mixed number is 3 1/4. Same with these shape models. You have a rectangle that's been separated into 3 parts. The mixed number is 1 2/3. And we're going to do these problems later. These problems to get after we're done reading the book. On a number line, you can see how far away whole numbers and fractions are from 0. Have you done fractions on a number line before? I figured. So the tick marks between the whole numbers on the number line below represent mixed numbers. This mixed number is 1 2/5 because it is 1 2/5 units to the right of the 0. The number line is marked, this number line is marked in thirds. So use the whole number, distance from 0, and the number of thirds to the right of the whole number to name the points. Okay, so we're going to come back to that. Mixed numbers and improper fractions. You can label a fraction number line in a different way. Continue to label the fractions in fifths on this number line. Okay. They've done this for us. They go from 5/5, which would be 1, to 6/5, 7/5, 8/5, 9/5, 10/5, 11/5, 12/5. I don't know why I have a hard time saying that. 13/5, 14/5, 15/5. Okay. And those are all improper fractions. And there's nothing wrong with improper fractions, they're just top heavy. An improper fraction is a fraction whose numerator is greater than its denominator. So this bug has landed on 1 3/5 or 8/5. And they have the same exact value, that they are equal to each other. 1 3/5 would equal 8/5. Remember, when the numerator and denominator are the same, the fraction equals 1. Oh, that pencil. To write a mixed number as an improper fraction, write the whole number part as a sum of ones. So you can write each one as a fraction, like 3 1/4 would be equal to 4/4 plus 4/4 plus 4/4 plus 1/4. And they all have the same denominator, right? They have a common denominator, so they add the numerators and keep the denominator the same, and you would end up with 3 1/4 or 13/4. To convert a mixed number to an improper fraction, or from a fraction to a mixed number, is to change from one to the other. And again, we'll come back to those. Add and subtract mixed numbers. So when you're adding mixed numbers with the same denominator, convert all the numbers to improper fractions and then add. So if you have 2 3/5 plus 1 4/5, that would equal 13/5 plus 9/5. Now that you've converted them, you can add them. 13/5 plus 9/5 equals 22/5. Add the numerators and you keep the denominator the same. And then you can convert it back to a mixed number. The answer is 22/5 as an improper fraction, or the answer is 4 2/5 as a mixed number. So here's another way to add mixed numbers with like denominators. They have 2 3/5 plus 1 4/5 equals 2 plus 3/5 plus 1 plus 4/5. So they're taking the whole numbers, 2 plus 1, adding them together to get 3, and they're taking the fractions, 3/5 and 4/5, and adding them together to get 7/5. So you end up with 3 7/5.
Or 4 2/5.
Or 4 2/5. Thank you. Yep. The commutative property says that you can change the order of the addends without changing the sum. Just like if you have 3 plus 4 equals 4 plus 3, you can also change that when it comes to fractions, where you have 2/5 plus 1/5 equals the same thing as 1/5, would be the same thing as 1/5 plus 2/5. Nice, right? Can you do that when you're subtracting?
Mm-hmm.
No. Subtract mixed numbers. To subtract mixed numbers with the same or like denominators, convert all numbers to improper fractions and then subtract. So that's a little different. You cannot move the order around when you're subtracting, right? All right. So write each mixed number as an improper fraction. Keeping the denominator the same, we subtract the numerators, which is 29 minus 11, giving us 18 eighths. Convert it to a mixed number, 2 2/8. And then we can simplify the fraction by dividing by the largest number that goes exactly into both 2 and 8.
Which is 2.
Yeah. Remember when we were talking earlier about simplifying? I told you we'd come to that in the book. When you simplify, you're finding an equivalent fraction with the smallest possible denominator. So you're reducing it down. I mean, if you had 50 1/100ths, would you want to keep it like that, or would it make sense to...
1/2.
Yeah. 50 1/100ths is the same as 1/2, but that's a pretty big fraction, so it does make more sense to reduce it to 1/2. Especially if you're going to be using it to do addition, subtraction, or other things. Unless the only common denominator you had was 100. Alright. When you simplify, you're finding an equivalent fraction with the smallest possible denominator. To find an equivalent fraction, multiply or... Did I already say this part? Multiply or divide numerator and denominator by the same number. Sorry. Back to the pizza shop. Suppose your team celebrates a win. There are 2 3/4 pizzas left on the table. The players are not done eating. They eat 1 2/4 pizzas more. How much pizza will be left? So, let's go. We'll come back to this later because we're gonna go through the book again and I'll have you guys solve all the problems, And since you're my only student, that'll be you. Common denominators. We talked about this. When the denominators are not the same, you need to find a common denominator in order to compute. And you showed me that you could do that. Use equivalent fractions to make the denominator the same. Sometimes one of the denominators is the common denominator. If one, like in your problem, the problem that Aurora showed us, 1/5 plus 2/20. 20 was the common denominator. If one denominator is a multiple of the other, use the larger denominator as the common denominator, which is what you did. Alright. Multiply with mixed numbers. They're using a number line to do that. Have you gotten to this yet? Alright.
We passed that.
3 times 1.5. 3 jumps of 1.5 land at 4.5. So 3 times 1.5 equals 4 and 1/2. And if you want to do a calculation, you'd have to make that mixed number.
1 plus 1 plus 1 gets you to the 3, and then 1/2 plus 1/2 plus 1/2 gets you to 3 halves. Otherwise, it was 1 and 1/2. So you add your 3 and 1/2, or your 3 and 1 and 1/2, and you get 4 and 1/2.
Yeah, but you'd have to change that mixed number into an improper fraction, right?
Mm-hmm.
Write the mixed number as an improper fraction, and then you multiply the numerators together and the denominators.
Oh yeah, we were doing that in class today.
Perfect. Well, I was trying to find something that would be...
Well, for the past week or so, we've done the 3 times 3 on top, but we didn't do anything on the bottom.
Multiplying numerators and denominators?
Well, we weren't multiplying other fractions, we were multiplying whole numbers. So the 3 times 3 on the top, and then just the 1 on the bottom.
Okay, so whole numbers turned into fractions, 3/3 would be a 1.
Yeah.
Okay. Then you can convert it back to a mixed number, which you already know how to do. Every whole number can be written as a fraction with 1 in the denominator. So the number 2 would be 2 over 1. And if you want to double check that, you can say 2 divided by 1. How many times?
2 divided by 1 would be 1.
2 divided by 1 would be what?
2.
Yeah. 3 divided by 1 would be what?
3.
Exactly. So. Now this is dividing with mixed numbers. Have you gotten to that yet? If you haven't gotten to that yet.
No.
Okay. We probably will skip that part because it's not something... my purpose today is not to start something that you haven't done before, so. I wanted to show you at the end of this book, you'll be using later, what is this handy dandy thing here?
Numerator.
Well, what is this?
Glossary.
And it has... What does that glossary help you with?
I don't remember what a glossary is.
Well, what does it look like? Use your clues on the page there.
It helps you out with words that you may not have been able to know and the definition of them.
There you go.
Kind of like a dictionary.
But for the specific book.
Yeah.
High fives. You got it. That's exactly what it is. A glossary is kind of like a dictionary.
I partly remembered it.
Yeah.
But
It helps you with terms. Alright, well, I'm going to go back together and then go back to the beginning, and then the next part of our lesson is letting you do more of the work. Okay. So help me out here. Normally I'm doing this lesson, I would be calling on multiple students, but you're my guinea pig, so the top, okay, that page doesn't have one. I said we come back and do these. Okay. So, what mixed number does this model show?
3.5.
All right. What about the second model?
1 and 2/6.
Correct. Okay, last one.
3 and 3/5.
Yes. Just have to read upside down. Trying to cover up the answer. If I was holding up a regular book, I would have had it covered up with a sticky note, but
I'm not looking at you.
I know, but I'm just saying it is different when you're reading a book that's an online book because you can't use a sticky note on it. I suppose I could try, but just be patient with me. Let's see. So this number line is marked in thirds. Use the whole number distance from 0 and the number of thirds to the right of the whole number to name the points. Okay. On what mixed number did the bug land?
Here.
Yeah, A.
1 and 3/6.
Correct. How about B?
2
Aurora.
and 3/4.
You're my only person to choose. And C. Yes, ma'am.
3 and 1/2.
You got it. This page does not have an extra problem. KK, here we go. What is 1 2/5 as an improper fraction?
1 and 2/5. 7/5.
Got it. What is 17/4 as a mixed number?
4 and 1/4.
Excellent. Alright. Here we have a word problem. Suppose your team celebrates a win. There are 2 3/4 pizzas left on the table. Now you can use paper if you need to for this. The players are not done eating. They eat 1 2/4 pizzas more. How much pizza will be left?
1 and 1/4. Because 2 minus 1 is 1. And then you've got 1 and 3/4 minus 2/4 is 1 and 1/4.
You mean you have 3/4 minus.
Yeah, 3/4 minus 2/4.
Yeah. Now you're lucky because the numbers that you might have to convert it if it didn't work out that way. But yeah, you got it. I guess if I was doing the class, I might have somebody try it with the number switch. So, maybe if you had 2 and 2/4 minus 1 3/4 or something like that, then it wouldn't be as easy to do it that way. Thank you. The team spent 1 2/6 hours at the pizza shop and 5/6 of an hour on the team bus to get home. How many hours did they spend on both activities?
3/6.
How many hours did they spend on both activities?
Oh, on both act.
Yeah.
2 and 1/6.
That is correct. Okay. If you walk your dog on a trail 2 2/3 miles long and continue on a different trail for 1 1/4 miles long, how far will you walk your dog?
They have different denominators, so we have to find a common denominator.
Mm-hmm.
And 3 plus 3 is 6, plus another is 9, plus another is 12, so 4 fits into 12. 4 times 3 is 12. And so we're adding 3 and 8.
I think Vinny. Okay. Sorry about that.
So it's 3.
Do you need to make 2 improper fractions to
If
figure
I had a
this out
pencil,
too?
can I use a pen, please?
Oh yeah, I forgot your pencil broke. That stinking thing. Like, think all the lead up inside that is broken. I can try to sharpen it again while you're doing that.
Three and 11/12.
Okay, can you show us how you got that answer?
Okay, so I did the first part of it in mental math. What you didn't mean to actually show you. So I did the first part of it.
No,
in
you
mental
can show everybody.
math. It doesn't show up on the camera. It's too
Well,
bright.
you show me.
So 1 plus 2, I got that 3, and then I converted them into 12ths, and I did 3 times 4 equals 12, so 2 times 4 equals 8, 8/12, and then 4 times 3 equals 12, so 1 times 3, 1 times 3 equals 3, 8 plus 3 equals 11/12, and then we add our 3 and 11/12.
Okay. Let's double check your answer here. Looks like you did good, kid. Thank you for showing us that. And if you had to label that answer, what would you label it?
Miles.
So
3 and 11/12 miles.
thank you. All right, here's a good one. Because you guys are growing so much. If you were 52 and 1/8 inches tall last year and you are 55 and a half inches this year, how many inches did you grow? What kind of problem is it asking you to do, Aurora?
Well, I guess subtraction is 55 minus 50, 51 and 1/2 minus 52 and 1/8 would get us our answer.
Yeah, so you're finding the difference between how tall you were
And the
last
common
year.
denominator can be 8.
Okay, you can get up and show us.
So I'm converting that 1/2 into 4/8.
Hold on just a second.
Alright, so like
Go
I
ahead
said,
and show the class.
like I said, we're turning that 1/2 into 4/8. And then we've got our 1/8.
Okay, because you're saying 8 should be our common denominator for the...
Yeah. 4/8 minus 1/8 equals 3/8. And then 55 minus 52 is 3. So 3 and 3/8.
Okay. Let's see. They agree with you. This pencil is inherently bad. Okay, here's one of our questions. Aurora, could you help us with this? You read a punch recipe that needs 3 3/4 cups of juice. How many cups of juice will you need if you make 4 times as much?
Well, 3 times 4 is 12, so we've got our 12 as our whole, and then 4 times 3/4, 3 plus 3 plus 3 would get us to 9/4. So 9/4 will equal 2 and 1/4. 12 plus 2 and 1/4 equals 14 and 1/4. So you would need 4.
I think you might have gotten... You're multiplying 4 times what?
4 times 3 and 3/4.
Okay.
Wait, I can just do this.
You can split it up and say 4 times 3 and then do 4 times 3/4.
Yeah.
And then add the sums of those together.
Yeah.
Or you can just make 3 3/4 into a mixed number.
No,
Or not a mixed number, excuse me, an improper fraction, and multiply by the improper fraction. Do you want to try that?
Mm-hmm.
Okay.
Well, the improper fraction would be 15/4.
I agree. Because you got 3 times 4 is 12, plus the 3 from the numerator would be 15/4. Okay.
4. I'm doing a strategy that we learned in class. You do the 15 times 4 on the top and then the 4 on the bottom. So 15 times 4. 15 times 2 is 30. So 30 plus 30 is 60. Then you have a 4 as one denominator. So 60 divided by 4.
Can I show you something?
Mm-hmm.
Okay. I think that you're getting a little bit confused. If you want to just multiply two fractions times each other, what would 4 be as a fraction? What would 4 look like as a fraction?
Well, it would look like 16/4.
True, but when you're multiplying, you're not worried about the denominator being common. So you're doing too much work for yourself. So what would
4
you...
ones.
4 over 1. Yeah. Thank you. And then what are we multiplying the improper fraction that we made?
15.
50. Okay. So we're multiplying 4 over 1, or 4, which is 4/1, I guess. I don't know how you would say that.
4.
Times 15/4. So when you're multiplying fractions, do you have to have a common denominator?
No.
Why? Because you're multiplying the numerators times each other, and then you're multiplying the denominators times each other. Okay, so help me out that way.
That would equal
Show everybody how you would do that.
60,
Awesome.
which is exactly what I got down here.
Honey, I'm sorry. You were exactly right, and I screwed up. You did get 64. You just did it a different way from me. Okay, I guess I was confused. Is that a 4?
Yeah.
Okay. Your 4s are different from my 4s.
What do you think it was?
No, it's okay. Alright, so 64s. If you wanted to turn that back into... If you wanted to reduce it...
Reduce it by 2 to get it to 3 halves.
Does 4 go into 60, though?
No, but 2 does.
Are you sure 4 doesn't go into 60?
Well, if 2 does, then 4 probably does,
Yeah, because you could reduce this even further.
16. 60 divided by 4 is 16. Right?
Nope, close. I don't want to confuse you, but 4 times 15. Because thinking about it, like, 2 goes into 30. 2 times 15 would be 30, so.
So that's 15.
15. Yep. You could also try to turn it back into an improper fraction, but you get, like, the same thing, so. or mixed number. I'm not making any sense. I'm really sorry. When we got interrupted during our lesson, I think I got off track, so. I apologize for that. Alright, so I'll remind you guys again that there is a nice little glossary in the back of your book that you can use. And for part of your, because the first part of your independent assignment will be that you're, I apologize. You're going to be, and this is up on the board, you're going to be putting defining these terms in your math journal. Mixed number, numerator, denominator, proper fraction, and improper fraction. And those will be on the board for you. And if you want to look something up in the book, that is also a good reference for you because it's most of the definitions are in the book itself, not just in the glossary. If you want to find a part of the book that you remember it being in, that's also fine. And when you're done writing those definitions down, there is a little quiz. Okay? Right there where it says take quiz. Okay, so I will let you use your computer to do that. The first part of the assignment is to define those relevant vocabulary terms in your book, and then why don't you can you do me a favor and before you take the quiz, do your math journal
Mhm.
and then take the quiz?
What would you like
Because that will help you with,
What would you like me to put in the math journal?
remember I said these terms?
Mixed number numerator.
Yeah. I don't have a smart board, but if I did, they'd be up on the smart board too, or up somewhere.
Here we go.
You got those 5 terms? Because it looks like... Okay. So,
And I can take the quiz now?
you have to write down the definitions for your
Oh.
math journal.
Okay.
I thought... Am I being confusing when I say that? That's why I said you could use the glossary or go back in the book. Either way, that it's a reference for you. There you go.
Alright, common denominator. In a fractional number. Proper fraction does not seem to be here.
What's the same thing as... Well, they have improper fraction in the glossary.
Well, a fraction that's numerator is lower than the denominator, or the same size.
Yeah, you can go back into it, but like it's just where the numerator is smaller than the denominator. Yeah. If you have any questions, I don't mind. It's Okay, so just a reminder that when you finish your writing in your math journal, you can go on to the book quiz in Epic. And you don't forget you can yes, and don't forget you can scroll down. You might have to scroll down to see all of the possible answers. Okay, thumbs up if you're done with your quiz. Okay, now that everybody's finished with their quiz, I don't know if everybody would be that fast, but now that everybody's done with their quiz, we can finish up the lesson. Did you think that writing the definitions in your math journal helped you on that quiz?
Yes.
Why?
Because I got to look at the meaning, and I got to look at what the word was and what it meant.
Before you took the quiz?
Mm-hmm.
And then what was on the quiz?
On the quiz was questions about what the words meant.
So it helps you to know the correct definition, right? Some of them a lot of you already knew the definitions, but was it a good refresher? Okay. So you can use your book to help you out with this one. Why is the commutative property important when adding and subtracting mixed numbers?
What's commutative?
Okay. Use your book. If you want to look back in your book to see if you can find that will help you. It's in there. We'll be keeping this book in our favorites, so you can use it as a reference if you're stuck at home or in class. Hold on, I think.
Do you know the commutative property? Not changing the song.
Okay.
Okay, what was the question?
So, is the commutative property important when adding and subtracting mixed numbers?
When adding, yes, but when subtracting, no.
Because the commutative property says
it only applies to adding.
Yeah,
if you mix the numbers around when subtracting, then you won't have the same answer, or you won't be able to get the answer.
Good one. I think I wrote that badly in my lesson plan, but yeah, it's helpful in adding. So you cannot change the order when you're subtracting without messing up the answer. So go ahead and record in your own words if you want. You can record what they have in there, or in your own words what the commutative property is.
Communicative?
Commutative is commutative.
Commutative.
Yeah, I know. So can you record that in your math journal and before you drop it off with me at the front. That is your exit ticket today. Because I have your answers for your quiz in my Epic account. Your exit ticket? Thank you, ma'am. You are finished.
Goodbye. Have a nice day, Mrs. Bride.
You too, Aurora.